Hello everyone, welcome back. In this tutorial, we're gonna see a directory structure in Linux. Let's talk about the important directory called as slash. It also known as a root directory. This root directory we called as a top level directory. Let's move on the operating system and let's check the root directory. So we are in the root directory slash. And if we do ls, we can see here multiple important directories. These important directories are very vital to run the operating system. So for any Linux operating system, we'll see the slash and it's gonna mount it as a single partition. You can see here this mount point is slash and it's coming from the device mapper called as cl-root, and the total size of the slash is 50 GB. All right. Now let's talk about another important directory in Linux operating system is slash bin. Slash bin contain the executable programs. So if we run any executable command, so that command is stored in slash bin. We do not have to get confused between slash usr bin and slash bin. Another is slash usr slash bin. Both of the directories contain executable commands, but the difference is that the bin contain very significant commands that are required for rescue mode, for maintenance, and this is for the normal commands for any users. Let's move on the system and just do the demonstration. We'll move in slash bin. Slash bin contain important executable commands and programs, whereas slash usr bin also contain the important executable and program. The difference between that, slash usr bin is required for all normal users, where slash bin only we use in case of single user mode or maintenance or rescue mode. Let's move in other directories is slash dev. Slash dev is one of the very significant for any Linux operating system. It contains a hardware device file. Hardware device file, which is very important for Linux operating system. Now, what is hardware device file? Let us understand. For example, let me move on Linux box. Yeah. Slash dev. In Linux operating system, every hardware is treated as a file. Our whole operating system is treated as a file. So we can say that to run any hardware in Linux operating system, there should be a driver. So our device file is play the role of kind of drivers. So let's say example, if I'm running a CPU, or if I have the keyboard, mouse, or monitor, that is terminal, or memory modules, everything is treated as a file. So we user do not generally creates any files, any device file. By default, when you connect any hardware, it's create a file. In very rare case, we have to create or manually install the different hardware drivers. But this all files, which is currently we see in the slash dev, is already created by the operating system itself. Let's take an example. What are the different files are available? If I see the CPU here, right? So this is a CPU file. All right. So it says here D directory and C here And let's talk about other file like dm0, that is device mapper. This is another file. So there are multiple files. Now what users or administrator can do with this file? Let us understand why these files are very important for any administrator to go in /dev and perform some task. Let me clear the screen and do the ls again. Broadly, there are three different types of file or device file, we can say: the character file, the block file, and the network files. The character files is a file where the data flow one by one, that is bit by bit, and the block files where the read write operation happen with a chunk of data, that is in the form of blocks. Keyboard and mouse can be example of character files. Hard disk is an example of block files. And there are multiple network files which help to create a socket and communicate over the networks. How we'll identify the types of file? If we do LL, there are different types of file. So if we see the first letter at the beginning of LL output is a character file. C stand for character file, whereas B stand for the block files. This B stand for the block files. And if you notice here S, this stand for a socket files. Let's do one activity. If we do TTY, it's point out your terminal value. So TTY is, this is white screen is a terminal. So I'm asking on which terminal currently I'm working. So it says you are working on PTS. Under PTS, there is a value 0. So what is PTS? If you are working through the terminal, and you will get a terminal value. So if I do the duplicate session on the session and log in to the system again, and here if we do TTY, we get on the terminal value, that is PTS1. So if we see the path, these all files are located in /dev. So /dev file have the terminal files which is under the PTS1, PTS under 0, and other files are also there, like we can just scroll up this one, TT41, TT42, but currently we are getting a terminal value from PTS, excuse, no slash. All right, so here two files are we are working. One is for this terminal, another is for another terminal. Why we are getting from the PTS? Because we are accessing the graphics is installed, and if the command line is installed, you will get TTY1, TTY2, something like that. But anyway, these terminals are actually output for anyone. Yes, let me demonstrate that. If we do here PTS, so the value is /dev/PTS/1. So we'll copy this and we'll just say here echo hello, and we'll type this value. Here we'll say a greater than sign. Now this value need to be printed on this terminal. We'll go on the another terminal and we'll see here the value is already printed. So this terminal value is PTS/1. So this is a device file, and let's check the type of file. So if we do here LL, it's a character file. As we discussed, the devices which are r- takes the data in sequential way, it's known as a character file. So this file is a character file. So same way we have multiple files like for uh, hard disk, CD-ROM, right? So this is a SDA1. SDA1 is or hard disk. So one stand for the partition number one. This is for partition number two. SDB is another hard disk. SDC is another hard disk, right? So any hard disk, that is SCSI or SATA, is represented by SD, that is hard disk, and A means hard disk number one, partition number one. Hard disk number A means hard disk number one, partition two. B means hard disk number two. If we have SDB1, that is means hard disk number two, partition one. SDB2, hard disk number two, partition two. SDB3, hard disk number two, partition three. So forth and so on. Like for CD-ROM, here we can see that SR0 somewhere here, SR0. Let's point out that file, SR0. So SR0 is seems not available. So we need to check whether CD-ROM is connected or not. Let's come out and just check. I'll go in the storage. As of now, CD-ROM is not connected. That's the reason we are not getting. If we, it's on fly, it's not allowing us to connect. So if we turn off the system and start the system, SR0 will point out. Let's check that. Just I will power off the system and we'll connect one CD. And this to this CD will attach one ISO image. So we'll attach one ISO image of CentOS. That's fine. Now we have attached one CD and connected one CentOS image. We are starting the system. So it takes few minutes to boot. So we got login on the server. System is booted. Now let's move in the device file again. Now do SR0. Now this file automatically got created because this hardware was not present, that is CD-ROM was not longer present. So that's the reason here it's showing no such file and directory. After connecting a CD-ROM, we can see that its a category is B, that's a block device, and we can see the SR0. Now let's mount this device and use it. So we'll create a one directory for mounting it. So I will create a directory my CD and we'll say mount / dev SR0 my CD. Now we'll go in my CD and we can access the content inside the CD. So in Linux operating system, if you want to access any CD, first we have to mount it. So to mount it, we can use the command mount, and after that the complete device file name. So /dev /SR0 is our device, and after that any directory where we want to mount. This command mount the device called as SR0 on my CD. All right. Now this is a temporary way, but we in the future videos we are going to see more on mounting, but as of now we have just tested it using /dev/sr0. There is a another directory called as /etc. Let's talk about /etc. /etc is a directory which contain house of all system related configuration file. So config files. So all configuration files it's stored in /etc. So more time the system administrator will be in /etc. So all the system configuration files residing in /etc. So when we do the configuration of any DNS, Apache server, DHCP server, Samba server, we have to come in /etc to do the configuration. Let's talk about another file called as /home. A /home is a directory which contain the user related files. So we can say the users directory. So all user related directory that like users home directory or user related any directory can be stored in /home. Like for example, if you have the user called as admin, you will be having a directory called as /home/admin, and all the data or all the work of admin user it gonna store inside this, right? If you have another user called as abc, you will have the home directory for this user like /home/abc. All right, there is a directory, another directory called as /lib. Let's talk about /lib. /lib contain the shared library, images, and the models, which is essential to run the all the commands, programs, or boot the system. So this is a shared library which is required for the system to run all the commands, all the programs, and also it's help us to boot the system /lib. Another is /opt. So whatever the third party software or program we installed, that packages reside in /opt. All right, so if you try to install the Chrome, so my Chrome related all the files will get stored in opt, which is a not pre-installed by the standard Linux operating system. Like for example, uh, if you install Apache, you will not find any configuration in opt, because it's a standard software. It will go into the /etc, binaries will go in the /bin, library will go in the lib. But for third party, which is not standard from the Linux operating system, the third party software files, configuration files go into the /opt. Another important directory is /proc. /proc is a virtual file system. Why we call virtual file system? Because once you turn off the system, no longer the proc exists. So it will going to flush, it will going to automatically delete it. When you on the system, it going to automatically create it. So it contain the system information. All right, and that is used by all running program, right? If any program need any value, you will get it from the /proc. Let's demonstrate it. So we'll go on the Linux box and we'll move in /proc. All right, we'll do pwd. In slash proc we see multiple different files. Let's take any file like cat CPU info. So this is information about CPU. So number of processor is 1 and number of CPU core is 1, right? Let's take another cat mem info. This is memory information, right? So if we just scroll up, we can see the detail. The total memory size is around 2 GB, out of free is around 1.3, available memory is 1.4, right? So all memory detail. So all the processes which is running inside that, so these are the process directory. The number which we are seeing, it's the process ID, and for each process detail is stored in the directory format, and for each process there is a directory created by the system itself. So all the data related to your system is gonna stored with proc/proc. Let's talk about another directory called as /root. This is another /root. It's not a normal slash, so this slash is different. This slash is a root directory, and this slash is a root user home directory. This is a root user's home directory. What it means, there is a user called as root, right? And the root user's home directory is /root. It's unlike from the normal user. For normal user, the root directory will be in /home and the username. But for the root user, the root directory will be in /root. So this is a home directory for user root. All right. We have another directory called as /sbin. All right. /sbin. So /sbin contain the executable programs, commands for system level settings, right? For system level, that means it's not related with the user, not related with any users. It's only system related settings. Like for example, networking, like for example, IP config. So this is a networking command. So these all commands which I'm typing here, IP tables, right? fdisk, which is a disk management utility. So this all command gonna store in sbin. It's not related with any user, so that's the reason it will not going to store in usr bin and /bin. It will gonna store in /sbin. All right. Let's talk about another directory called as usr. So as we know that it's contain all the programs and the shared libraries related with the user. All right. Okay. So all the programs and it contain shared library, shared lib. Also it contain the executable file for the users, right? Another important directory in the Linux is /var. It contain variable files. What is variable file? Which keep changing, right? So the file which keep changing is called variable files, like log, right? Printer jobs or printer spools we call it. So this kind of file store in the /var. So what we have learned, we have talked about the Linux directory structure. We have covered the root, bin, usr bin, dev, etc, home, lib, opt, proc, /root, /bin, usr, and var. So these are most important directory in the Linux operating system. So we are going to interact with this all directory when we are working with further Linux configurations. Thank you so much.